Hello, my name is Anjan Madvesh, and I'll be presenting my final project as a part of the data analytics course at the Harvard Extension School. This is spring 2015. The project is called the Worldwide Auto Liability Insurance Risk Profile Visualization using D3. Basically, we'll be using the uh, features provided by D3 to understand how it can be applied in real world, particularly with the insurance industry. So to begin with, let's get an overview of all the different concepts and stuff that we'll be touching upon today. First is related to insurance. Insurance has been around for ages, and basically it has enabled human beings to, assume risk and scale new heights. And we'll see how all that works in a little bit. And so there's no real clairvoyance in the real world, so we need insurance. Insurance depends heavily on statistics. So what statistics? It's the next best thing to clairvoyance, meaning, we can't predict the future, so we use statistics instead to try and understand what the future will most likely be. Statistics and information technology are like soulmates. So, how does information technology fit into this? This is again in another, I believe, noble human initiative and has furthered, human causes for the greater good, like nothing else before. Now, within information technology, there have been many disruptive technologies. What this means is they basically change the way we look at things and is harnessed and when it becomes rather when it gets harnessed in ways we not even imagined by designers, it is fantastic. And it has the potential to change the basic nature of the business that wanted to use it to begin with. So that is so cool about it. And finally, data visualization. Now, if a still picture is worth 1,000 words, then what would be a picture that also answers your questions worth? So computer graphics, raw data to provide visual information, and putting it all together is the art and science of data visualization. So as a next step, let's take a deep dive into the insurance industry. Insurance is the business of risk management, meaning that we need insurance in good or difficult times. Anytime we are taking risk, we need it. At best, insurance basically allows us to take greater risks. So if we insure a satellite launch, then we can try out a few different things and ensure that we keep scaling our barriers, or we keep going ahead of our barriers and build new and grand things. It's important to understand that insurance is usually available for untoward events. And by that, for example, if you cover malpractice, or rather, if you buy malpractice insurance, and that doesn't mean that it'll cover you for stuff that is knowingly committed by you. This is mostly because that would be considered insurance fraud. However, you can buy insurance to cover yourself from malpractice claims for damages that resulted from activities you unknowingly committed. This difference is very critical for insurance to know because fraud is a serious issue for insurance. In the US alone, we have something like 80 billion lost by insurance, and all that kind of comes back to us consumers because in the grand scheme, when there is fraud, and the companies increase their premiums or reduce our coverages. So it's not a good thing for us. And then insurance is, significantly not again affected by the ups and downs of the industry per se, because when there is an up or down, the whole idea is that insurance is there to cover us during those difficult scenarios. So they have to be strong when we are, not all that strong at that point. So and as because it is so important, insurance industry is very heavily regulated by governments, very similar to banking and other financial industries. And the fact that insurance industry was not significantly affected by the recession that followed our subprime mortgage crisis recently, or in major catastrophes like Katrina or 9/11, demonstrates the solidity and the credibility of this industry, and in a grand way, the contribution to our society. Now let's take a deeper look at the technology that we are trying to showcase here, that is D3. D3 is basically a data-driven document. That's what it's called, and it's a powerful. It provides powerful interactive graphics, and it can be played on a browser. It promises to be another disruptive information technology, like how, for example, Java at some time was, or CSS was, or COBOL was when they were actually launched. D3 is almost like a programming language that sits on top of another programming language, which sits on top of another one. So it's like, it drives JavaScript, which in turn drives HTML. D3 is a list of basically JavaScript libraries. D3 is not initially intuitive when you start trying to work with it because it's not similar to anything you probably have seen before. But at the same time, it provides the ability to get a lot of stuff done with very little source code. So it's a pretty cool thing in that from that perspective. It's not exactly big data technology, but it's frequently used with other big data technologies like Hadoop. It uses processed data, so that's why it's called the data-driven document. It uses the processed data from the from Hadoop and so on, and then it'll generate pretty cool graphics using that. And the reason why we have it shows so much promise is because, especially for the insurance business, is because of its promise to help with creation of additional revenue or reduction of expenses. And that's a good thing for us all because that means insurance companies can actually invest more funds into doing better and providing better and grander products and services. And D3, like I said earlier, is a JavaScript library to create data-driven documents. It was developed by Mike Bostock, Jeff Heer, and Vadim Ogievetsky in Stanford University in 2011. There was some little bit of history prior to that. They had other products which they kind of, used as the source eventually to come over D3. D3 is not supported by all browsers. The older ones like Internet Explorer, earlier versions of Internet Explorer, because it outputs SVG, which is a markup, which is scalar vector graphics markup. Basically, that is not recognized by older versions of IE because IE used to at that time support VML, which is a vector markup language. And not support SVG, but the newer versions of IE are actually now supporting SVG. So then if you have a newer version of IE, this D3 stuff should work for you. Okay, now it's time to look at D3 actually in action. So what you're seeing in front of you in the screen is actually not a picture. It is created using D3. You can create it very easily, and well, it's easy in the sense of being able to create this kind of a graphical representation, but there is a lot of things that need to be done in terms of data massaging, and more importantly, to first identify what we want to get done. So we will talk about those aspects coming forward. So before we start delving into D3, let's look at the problem that we are trying to solve. The worldwide statistics are available in different publications related to automobile industry and health. However, there is no immediate report available that links the number of registered automobiles in a country with the number of fatal accidents per year in that country. Now, information that links these kind of figures would actually provide very important, information to the global insurance and reinsurance companies. They can use this information to adjust their premium or change their coverages in different geographies, and perhaps even determine if it is feasible to do business in a particular country. The approach that we have to use here is as follows. First, we download countrywide registered vehicles data from global health observatory data repository in the in the World Health Organization. This information is available in the appendix. You can take a look at the download links there and download this yourself. And likewise, from the same link, we can actually also download the road mortality data, meaning, basically how many fatalities or fatal accidents there were, or how many people, died as a result of accidents in those countries in the same year. And both of these downloads are yearly data, and in particular, I've used 2010 data. The other thing we need to do is download the latitudes and longitudes of different countries. And I chose to use the country capitals to determine the exact latitude, longitude positions. And that data is also available for download. CSG network for country GIS data offers this. You could use this or any other that you're more comfortable with. Now, after this, we merge all of this data into using MS Excel. And we'll talk about that in a little bit detail down the line. And then we calculate what I call as a risk profile for each country. That is a ratio of the number of fatalities to the number of registered vehicles. And once we have this ratio, then we create a distribution of bins and categorize each country in one of these 6 bins that are representing from low to very high risk profiles. Once that's done, we massage that data and plot it on a world map, the one that you just saw earlier, using D3's mapping feature called data map. And we'll also create a bubble chart using D3's pack layout. And doing all this, finally, we'll serve these as web pages on the local machine running a WAMP architecture. That's Windows, Apache, MySQL, PHP, although the latter two, that is MySQL and PHP, we will not be using in this. So at this time, we'll start looking at the data. So the raw data looks something like what you're seeing in the screen. This is when it's downloaded. You have, these World Health Organization allows us to download data in XLS formats. So we see for these countries, for example, for Afghanistan, you see for 2010, the estimated number of road traffic deaths was 6,200, while as the number of registered vehicles in Afghanistan was 700,000 roughly. And we also get the latitude and longitude information for Afghanistan, where for Kabul, its capital, where the latitude is 34 degrees north by the longitude 69 degrees east. The next step here is to process this data. First, we will process the latitude and longitude in the D3 format. We use the highly useful VLOOKUP function in MS Excel to merge the data from the 3 sources to one data sheet with country column as the key. So the merge sheet has the following set of columns. You have the latitude, longitude, you have the capital, which we'll probably eventually ignore. Then you have the number of vehicle registered and the total fatal accidents per year. Note here that all of the countries data in all of these sheets is not available, so we take the intersection of the list of countries. So for example, if a particular country like San Marino does not have latitude information or does not have vehicles registered information, then it won't come into our group of countries for which we will present this graphics for. The next piece here is that latitude data is expressed in degrees and direction, but D3 application, the data map object in particular, expects this information in the form of decimals and plus and minus symbol for direction. So south and west are minus, and north and east are plus. And then instead of degrees, we've got to use decimals. So how do we do that? First, we create 2 columns called lat sign and long sign, which is latitude sign and longitude sign. And we use this formula that is shown over there to determine, basically search for the string S or W in the latitude or longitude column, and then apply the minus sign and -1 sign. If not, you will keep the +1. And then the next step is to replace within the latitude and longitude column everything that is a digit, everything that's a character like E or N, and then we'll also replace the degree field or the degree column here with the decimal column. So once we do that, we then copy over the sign from latitude and longitude of the column that we just created, which was lat sign and long sign. We multiply that with the latitude and longitude, and what you see is exactly as shown here below. So you now see that the degree is gone, and you see that the number, the n is gone, and then n or the e is gone, and then it's multiplied by +1, because in this case both north and east are positive, and where they are negative, you will see in your Excel sheet that it's multiplied by -1, or the figure is negative.